All right, so the reason this is called a unit circle is that the radius is 1 unit. It is a circle specifically where R is 1. Do you remember how last class the title of our notes was trig with any angle? Now we're going to do angles specifically where R is 1. Do you remember when we did Pythagorean theorem and R came out to like square root of 29 and whatever else? Like now R is going to be 1. The vertex or like of your angle or the center of your circle is the origin. So that's the point 0, 0. And so I have already taught you the compass points, like the north, south, east, west, up, down, left, right. We've already done those. Let's go around and fill in those because you do already know those ones. If you are right here and you have rotated nowhere, how many degrees and how much pi have you gone? These are both 0, 0 degrees and 0 pi. Now here's my question. If this is the origin and your radius is 1 unit, what is this coordinate point? 1, 0. If that's the origin, 0, 0, and this radius is 1 unit, that's going to be 1, 0. Yes, ma'am. I'm using the first color right now. Pink is mine. If you want to, you don't have to. If the colors don't show up real well on here, but when I take the picture of it and post it on Schoology, it'll be all nice and colorful for you. Okay. Now we're going to go up to the top. How many degrees was that? 90. So 90 degrees at the top. What was that in radians? Pi over 2. Good. Half a pi. Now, the coordinate point, if this is the origin and the radius of the circle is 1, we went up 1, what is that coordinate point? 0, 1. Now we're over here. How many degrees is this? 180. What is that in radians? Pi. And again, if this is the origin and the radius of the circle is 1, we went left 1. So what is that coordinate point? -1, 0. Perfect. Now we're down at the bottom. If you rotate all the way down to here, how many degrees? 270. What was that in radians? 3 pi over 2. Good. 1.5 pi. And again, if this is the origin and we went down 1, what is the coordinate point? You guys know all of that already. Okay. Now, this is where I'm going to like stop writing with that color to color code. Go over to the notes. I'm going to explain to you how we're going to get the rest of this and then we'll build the rest of the circle. Okay. But look how much of it you know already. You filled in a good chunk of it. You're all brilliant. Okay. Now, where the other angles come from are your special right triangles. So I'm going to review the 45, 45, 90, and then we'll fill that in. And then I'm going to review the 30, 60, 90, and then we'll fill that in. Now, you want to start thinking of this instead of 45, 45, 90. You want to start thinking of it as pi over 4, pi over 4, pi over 2, because that's what that would be in radians. 45 degrees would be 1/4 of a pi, pi over 4, 90 degrees at the top, that's pi over 2. Now I'm going to draw the triangle in quadrant 1 just because that's easiest, but we're going to reflect it into all 4 quadrants. So this is 1. Again, that's the whole point of the unit circle. It's that hypotenuse, that R value, the radius of the circle is 1. To get the other sides, I'm not even going to throw out the question and ask. Some of you might remember it, but it's been a minute. To get from the hypotenuse to the sides, you divide by square root of 2. Does that ring any bells, sort of? Like because I did teach it to you, but it was like a month ago, all right? So if you take 1 and divide it by square root of 2, when you rationalize that, what are you going to get? Square root of 2 over 2 is what both of these sides will be. So the R value is 1, both of the sides are square root of 2 over 2. We're going to go back to the unit circle and fill in those ones. We're going to do this slowly and build it like one at a time. So pick a different color. I'm going to use green this time. It doesn't matter. And you don't even have to color code. I just think it makes it look pretty. Right? We're going to go through and do all the ones that are halfway in between. So let's go around and do the degrees first. Here's 0. If we rotate to exactly in the middle, do you see the one that's in the middle? That would be 45 degrees. And you're gonna just keep on adding 45. So if you take 45 and add 45, you get 90. We already filled that one in. Take 90 and add 45 again. That's gonna land us here. 135, good. If you add 45 again, you're gonna get 180. We already filled that one in. Take 180 and add 45 again. See, some of you have a calculator inside your brain. That impresses me so much. 225. If you add 45 again, you're gonna get 270. We already filled up, but are you getting how we're doing like halfway in between each time? Okay, 270 plus 45. 315, good. And if you do 315 plus 45, what will you get? Oh my gosh, 360, that's the whole way around. Good job. Now let's go do the radians. We're gonna count by fourths. 45 degrees is pi over 4. So we're gonna count by fourths. That is 1/4. 2/4 is a half. So what's gonna go here? 3/4. And again, they all have a pi in them. I don't say the pi every time because it's a mouthful, but 1/4, 2/4, 3/4. What is one whole pi? 4/4. Good. So what's going to go down here? 5/4. This one's 6/4. Just reduce. So over here will be 7/4. 8/4 is the whole way around, and 8/4 would reduce to 2 pi. The radians are easier because all you do is count 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. In my opinion, I think the degrees are harder because I'm like, wait, I have to add 45. What on earth's that? Do you know what I mean? Like you just count. Put it away. Now, both sides of the triangle are square root of 2 over 2. So if you imagine a triangle being drawn in here, the radius is 1. This coordinate point is square root of 2 over 2, comma, square root of 2 over 2. Both sides are root 2 over 2. Now here's what's going to happen. We're going to take that and reflect it into the other quadrants. Not going to change. We're just going to end up with some negatives in there. When you take that and reflect it over here, what's going to be negative, the x or the y? Good. It'll be negative square root of 2 over 2, positive square root of 2 over 2. This is very redundant, which is actually what I kind of like about it, because you just kind of write the same thing over and over again. When you take that and reflect it down here, what are we going to put? Good. They're both negative. And then when you reflect it into the fourth quadrant, the x value is positive, the y value is negative. Now, if you want to, you don't have to, but I'm going to do it because, again, I'm going to take a picture of this and post it, is you can connect those and see the reflection happening. Hold on just a second, and then I'll turn this back right side up. You see that? Do your best. I don't have enough rulers to pass out for everybody. All right, now we're going to go back to the notes and we're going to do the 30, 60, 90. But are you all hanging in there so far? It hasn't like been terrible. I mean, okay. All right, so let me see, which one of these do I want to do first? Now 30, 60, 90, you want to start to think of that as pi over 6, pi over 3, pi over 2, because that's what that is in radians. Pi over 6 is 30 degrees, pi over 3 is 60 degrees, pi over 2 is 90 degrees. Again, I'm going to draw the triangle in quadrant 1 just because I think that that's easier. Let's do the smaller one first. We'll do the 30 degrees there. I guess I should have labeled these both 45. I sometimes forget to label it when it's 45 because like they're both the same thing. But those are both 45 if you want to put that in. So we'll do 30, 60, 90. And again, the hypotenuse, or that R value, the radius of the circle, is 1. Again, I'm not even going to throw the question out there because it's been so long at this point, but we'll see if this rings any bells. To get from the hypotenuse to the smaller side, you divide by 2. So if that's 1, that's going to be a half. And then to get from the smaller side to the bigger side, you multiply by square root of 3. So a half times square root of 3 will just be a half square root of 3, or square root of 3 over 2. So that's where that pattern comes from. It comes from the special right triangle. Now we're going to go back and do all of the 30-degree ones. Pick a different color. I'm going to do, what haven't I done yet? I'm going to do blue for mine. I'm doing blue. Are you trying to make yours the exact same as mine? Oh, okay. Mine's blue. My last color is purple. You guys are funny. Okay, so let's go and do the degrees. This would be 30 degrees. Add 30 again. 60, good. Add 30 again. 90, we already did that one. Add 30, yes, see, sometimes you already have them filled in. Add 30 again. 120. Add 30 again, 150. Add 30 again, you get 180. We already did that one. Add 30 again, 210. Add 30 again, 240. Add 30 again, you get 270. We already did that one. Add 30 again, 300, and then 330. And if you add 30 again, what do you get? Okay, just stop that. It just affects me. You're gonna be okay. Now let's go and do the radians. This time we're gonna count by 6, and it always sounds like I'm lisping when I do this. 6, okay? So it'd be 1/6, and they all have pi. I don't say pi every time, but they all have pi. That's 1/6. The next one would be 2/6. What would 2/6 reduce to? 1/3, pi over 3. That's 2/6. 3/6 is a half. We already did that. This one would be 4/6. 4/6 reduced to 2 pi over 3, 2/3. That's 4/6. The next one is 5/6. 5/6. And then what is 6/6? 1 whole pi. Good. What's the next one? 7/6. What's the next one? 8/6. That would be 4/3. 9/6 is 3/2. The next one's 10/6. 5/3. Good. It's just fractions. 10/6. The next one's 11/6. And then 12/6 would be what? 2 pi the whole way around. Cool? Okay. Here, watch, I'll point to it again. Ready? 1/6, 2/6, 3/6, 4/6, 5/6. This one's 6/6, 7/6, 8/6. This one's 9/6, 10/6, 11/6, 12/6 is the whole way around. This is not so confusing. Please stop that. All right, now look at the 30 degrees. If you imagine drawing the triangle in here, the hypotenuse is 1. This side would be a half, the smaller side. This would be square root of 3 over 2. So the coordinate point is square root of 3 over 2, comma, a half. Square root of 3 over 2, comma, a half. What we're going to do is take that and reflect it to the other quadrants. This is very redundant, which is the good thing about it. Take that and reflect it over here. Do you see where I'm pointing? Like straight across. This point is going to be what? Negative square root of 3 over 2, 1/2. Now take it down to here. They're both going to be negative. and then take it over to here. Which one's going to be negative? Good. Let me draw in the lines so you can see them. Yes. Oh my gosh. Hold on a second, Caleb. You're mentally ahead of me. Just wait. Okay. Well, I am, because I know some people like to see them. Also, when you're done, if you do all the lines, it looks kind of like a vortex or something. Cool. And I like when it's colorful. Yeah, it does. It looks cool. All right. Now, when you do the last one, it's still 30, 60, 90. It's just tilted the other way. And so as Caleb just said over here, isn't it just going to be opposite? Yes. It's very, very redundant. You just take the 30, 60, 90 triangle and it just goes the other way. So the short side and the long side got flipped. They're just reversed. So I'm going to use purple for this last one. You can use orange. Yeah, I guess every other one should have technically been a different color, but it's easier to just count by 30s. So I just went and filled them all in. Is that what? I'm sorry. You're being a little bit of a perfectionist. It's going to be okay. All right. So this last one. I had it up there for a while. Okay, that's okay. It's the exact same triangle as this one, just tilted the other way. Okay, thank you. So this one is going to be 1/2 square root of 3 over 2. And then you're going to take that and reflect it over here. So this would be -1/2 square root of 3 over 2. When you come down here, they're both going to be negative. And then in the fourth quadrant, it'll be +1/2 negative square root of 3 over 2. And I'm sorry, I guess technically those radians should have been written in purple. It's just easier to go fill them in the whole way around. I'm sorry. All right, there. What you think? Got the whole thing filled in. It does. It's like a yeah, it looks like it's like 3-dimensional sort of. All right, I'm gonna write a couple more things and then I'll give you a little break, okay? But we're doing well on time. So this is good. I'm trying to do this nice and slowly so that like you have to get this, okay? So here's the main takeaway. You have a small angle, a medium angle, and a large angle. That's really all that is. Small, medium, large. The small angle is 30 degrees, which is pi over 6. The medium angle is 45 degrees, which is pi over 4. And the large angle is 60 degrees, which is pi over 3. All you really have to remember is what side goes across from those. And do you remember from law of sines, law of cosines, that unit that we just finished? The small side goes across from the small angle, the medium side goes across from the medium angle, and the large one goes across from the large angle. So across from the smallest one, you're going to have 1/2. That's the littlest one. Across from the medium angle, you're going to have square root of 2 over 2. And across from the biggest one, you're going to have the biggest side, square root of 3 over 2. And you can remember this because look, it goes 1, 2, 3. 1, 2, 3. Smallest, medium, biggest. Okay. But this is the thing that you need to know. So I don't know if you want to draw like some stars around that or whatever, but you got to know that. So the whole goal with this is for us to evaluate the trig functions, so sine, cosine, tangent, etc., of these angles. So let's review real quick. You have this in your notes from last time, but let's just go ahead and write it again. This is your angle. Your right angle should always be on the x-axis. It is a reference angle. This is X, this is Y. The only difference between last time and today is I called this R last time, and remember R could be anything, and it came out to weird stuff like square root of 10 and all that. This time, what's R? 1 for all of them, which actually makes it easier because it's 1. All right, now sine is opposite over hypotenuse. Hey guys, that would be Y over 1, which is just Y. Good. Sine is the Y value. Cosine is adjacent over hypotenuse. That would be X over 1, which is just X. Tangent is opposite over adjacent, so Y over X. Now, for these ones, you're just going to flip them. Here is the thing that people get hung up on, are these two. Please do not put 1 over something. It just means to flip it. Just take what you had and flip it. That's it. Okay? So when you go to evaluate these, I don't normally write this out, but I know you guys need steps. You're like step 1, step 2, step 3, and I've got you. Okay, so here are your steps. Figure out what quadrant you're in. And guys, how many quadrants are there? 4. If you lose your mind, you have a 1 in 4 chance of guessing. And this is what I love about trig. Your world is so small. Like, I want you to understand what's going on, but the bottom line is if you don't, like your probability of guessing correctly is not bad. You know what I'm saying? Okay. Quadrant. Then figure out the angle. Your choices are these 3. That's it. If you lose your mind, it's one of these. These are the degrees, these are the radians. Pi over 6, pi over 4, pi over 3. Those are the choices. You only have 3 options. Then you're going to fill in the sides of the triangle. You only have 3 options for those. A half, root 2 over 2, and root 3 over 2. These are the choices, guys. That's it. Well, and you have those bullseye ones like 1 and 0. All the like the up, down, left. So, but like those are easy. And then you're going to do the answer. The answer is one of these 6. So do you want the Y value? Do you want the X value? Do you want to flip it? You know, like whichever one of those gives you. All right. So you're making fun of me? Oh, okay. Little speech for this. Because you can so easily guess the answer, you have to draw a triangle for every problem and label it with these things, the angle and the side. I say this every year, and every year someone doesn't listen to me, and I don't care if your answer's right, I'll still not give you any credit if you don't draw a triangle. How many sides does a triangle have? 3. Work with me. Not asking for that much, okay? You have to draw a triangle and label it for every single problem. There, I said it, and it's on the recording, so verifiable. All right, sine of 210. What quadrant is 210 in? That's the first step. 3. Draw your triangle in quadrant 3. If you look at that again, I'm taking it. Now the reference angle, there's a clock right there. Now the reference angle, that's this angle right here. If we went 210 and this was 180, what's left? This is like your quiz you just took. 30. Hey guys, it's gonna be 30, 45, or 60. Those are the options. Now you decide what goes across from that. Look back at the little cheat sheet I gave you. What goes across from 30? 1/2. Good. Put the 1/2 over here. If that's a half, what's the other side? Good. And then you decide if there are negatives. If you're not in quadrant 1, there are negatives somewhere. Is one of them negative? Both of them negative? Ooh, why are they both negative? You went left and down. It's quadrant 3. All right. There, we did all. That's the work I'm looking for. That is the amount of work I want to see. Does this make sense? Not that bad. All right. I want a triangle, angle, sides. Now we answer the question. The question is sine. Sine is the Y value, or you can think of it opposite, but sine is the Y value. Which one of these is the Y value? -1/2 is the answer. Let's try again. -300 degrees. First thing is, what quadrant are you in? Now we're going backwards, so be careful. What? Oh, good. Draw your triangle in quadrant 1. Then it's the angle. If you went negative 300 and the whole way around is 360, what's left for this? 60. Once again, it's going to be 30, 45, or 60. Those are the only choices. What goes across from the 60? Square root of 3 over 2. What does that mean the other side is? 1/2. Is anything negative? No, that's your work. Work is done. Now you answer the question. It says cosine. Cosine is adjacent, or you want to start thinking of it as x. But yes, it is adjacent over 1. Which one of these is the x value? 1/2 is your answer. This is a drill and practice thing. We're going to just do a bunch of these, okay? What's that? For this angle? So we went backwards 300, but the whole way around would be 360. So 60 is what was left. All right, 5 pi over 6. What quadrant are we in? 2. If you go 6, 6, that's 1 whole pi. 5, 6 means you didn't quite make it. And you can look back at your unit circle, see how 5 pi over 6 is right here. Quadrant 2. Now the radians are easier. Your reference angle is either pi over 6, pi over 4, or pi over 3. Those are the only choices. And the denominator will match. So if this says 5 pi over 6, your angle is pi over 6. If it's anything over 4, it's pi over 4. And if it's anything over 3, it's pi over 3. It's just going to match. I see you guys looking back. That's awesome. What goes across from the pi over 6? 1/2. What does that mean the other side is? Square root of 3 over 2. What's negative? Because something is. Good, the x value is negative because we're in quadrant 2. That is the work. That is the amount of work I need to see. Now we answer the question. It's tangent. Tangent is y over x, or opposite over adjacent. So it is 1/2 over negative square root of 3 over 2. Nobody panic. I know that looks awful. But what's going to cancel out? The 2's. And we get negative 1 over square root of 3. And then all you have to do is rationalize that. So it will be negative. Perfect. Square root of 3 over 3. It's got it. Let's try another one. Negative pi over 4. What quadrant are you in? 4. Because you went backwards. What's the reference angle? There's only 3 choices. Pi over 4. What are the sides of the triangle when it's pi over 4? They're both square root of 2 over 2. Now, one of them's negative. Is it the x or the y? The y is negative, so we went down. That's the work. Now answer the question. It is cosecant. That means you flip the y value. Okay, this one's your y value. I am only going to work through this once. After this, I want you to just know it because this is a complete mess. If you flip negative square root of 2 over 2, you get this. And when you rationalize that, you get negative 2 square root of 2 over 2, which will just be negative square root of 2. So hey guys, whenever you flip square root of 2 over 2, it's just square root of 2. So that you don't have to do that every single time because that was annoying. It's like attack of the 2, okay? Where is 7 pi over 6? Which one? 3, good. What's the reference angle? Pi over 6. See how there's a 6 there? It's just gonna match. What goes across from the pi over 6? 1/2. What does it mean the other side is? Good. Oh, and that's negative, and so is the 1/2 because we're in quadrant 3. That's the work. That's it. That's all your work. Now answer the question. It's secant. Secant means we're going to flip the x value. So we're going to flip this one right here. That would be -2 over square root of 3, and then just rationalize that. So -2 square root of 3 over 3. Where is -pi/6? 4, good. What's the reference angle? Technically it's 30, but I would still mark that wrong. If the question's in radians, you stick with radians. If the question's in degrees, you stick with degrees. What goes across from pi/6? 1/2. What does that mean the other side is? What's negative? Perfect. Now answer the question. It's cotangent. That is x over y. So it's going to be square root of 3 over 2 over -1/2. Nobody panic. What happens? 2's cancel. You get square root of 3 over -1, which would just be negative square root of 3. I'm going to pause. You guys try number 7. Because I won't have time to finish all these. What quadrant did you put it in? 2, good. I thought I heard somebody say it. What's the reference angle? Pi/3, it's just gonna match. What goes across from pi/3? Perfect. What does that mean the other side is? 1/2, but it's negative. That's the work. Now answer the question. Sine is the y value. Which one's the y value? √3 over 2. Cool. All right. If we go backwards 2 pi/3, that's going to put us in the third quadrant. What's the reference angle? Good. What goes across from that? Square root of 3 over 2. That means the other side is 1/2. What's negative? Both of them. Do you guys see how these are the exact same triangle but reflected? This just got reflected down here. It's the exact same triangle. All right, now you answer the question. Secant. That means we're going to flip the x value. Which one's the x value? -1/2. If you flip that, -2. These last 4 are the quadrant angles. This is your north, south, east, west. Instead of a triangle, you will get a circle. So draw like a little bullseye. Where is 3 pi/2? Just use words like up, down, left, or right. 3 pi/2 is down here. What is that coordinate point? 0, -1, good. It is 270 in degrees. We want the coordinate point. 0, -1. That's your work. Now you answer the question. It's sine. Sine is the y value. Which one of these is the y value? -1. Tangent of pi. Where is pi? Up, down, left, or right? Left. Pi is right here. What is that coordinate point? -1, 0. Then answer the question. Tangent is y over x. That would be 0 over -1, which is just 0. Cotangent of 0. Where is 0 pi? I should have put a pi with that. No pi. To the right. Good. That is the point 1, 0. Good. Cotangent is x over y. That would be 1 over 0. Now I did this on purpose so we could compare and contrast. This one's just 0, but you can't divide by 0, which means this is undefined. And as a foreshadowing, because we're eventually going to get there, and by the time we get there, you will all be fine. But we're eventually going to graph these, and what that means is that there's an asymptote in the graph. Okay. Where is pi/2? At the top. You can just say up, down, left, right, because that's, I mean, how we'll communicate that. So that point is 0, 1. Cosecant means you're going to flip the y value. That means you would flip 1, which just is 1. Don't stop listening to me. I want to show you delta math real quick. Okay, here we go. I'll be able to do this like on the recording. Okay, this is what it's going to look like. You're going to move this green dot to where it goes on the circle. Do you see this? Okay, where is 0? Right there. Okay, so I'm going to leave it where it is and then answer the question. It's sine. This coordinate point would be 1, 0. Sine is the y value, which would be 0. Let's try another one. What quadrant would 5 pi over 4 be in? 3. Do you guys see how you're getting that? Awesome. Okay, now you see how it's like you can do like small, medium, large. This one would be in the middle. The sides of the triangle would be what? The one with the 2, yeah, root 2 over 2, except they would both be negative, okay? Sine is the y value, so it would just be negative square root of 2 over 2. Let's do one more. Pi, where's pi? Okay, that coordinate point would be -1, 0. Sine is the y value, so that would just be 0. Actually, let me do one more because that one was another quadrant one. All right, 2 pi over 3, where's that? Second. Now see, this is right in the middle. This would be the third, because see, 6th would be smaller, 3rd is bigger, so it's going to be that one. That would be the point, -1/2 square root of 3 over 2. And they keep giving us sine. Sine is the y value, so it's going to be square root of 3 over 2. Do you guys get how you're going to do that? Move the point and then type in the answer. And I think they're only going to give you sine, cosine, tangent. I'm not 100% sure. The other 3 might be in there. I don't know. Maybe they are. All the ones I just did were sine, so we'll see what happens.